Quand il me prend dans ses bras, qu'il me parle tout bas, je vois la vie en rose. Il me dit des mots d'amour, des mots de tous les jours, et ça me fait quelque chose.
Okay, please don't judge my singing too harsh. I'm just here to bring this avatar to life. Hi, in this video you're going to learn how to bring a VRM avatar to life using React Fiber and Mediapipe for real-time face and hand tracking. We will cover what VRM avatars are, how to load and animate them in a 3D scene, and how to make them mimic your expressions and gestures with just a webcam. Before diving into the video tutorial, if you are new to 3D web development or want to build a solid foundation, consider exploring my course, React Fiber, the ultimate guide to 3D web development. A project-based course with everything you need to know to start creating professional 3D web experiences with Three.js and React. Let's have a look at what VRM are. VRM stands for Virtual Reality Model. It's a 3D avatar format widely used by VTubers and in games, thanks to its standardized structure that makes it easy to reuse the same character across different platforms and experiences. You can find free avatars online or create your own using the free tool VRoid Studio. There are also utility libraries available to load VRM models into engines like Unity and Three.js, making integration super accessible for developers. Let's start by cloning the starter pack I prepared for you, link in the description below. Click here to copy the URL to the clipboard. In a terminal, run git clone and paste the URL. Once finished, open the repository with open folder, open, and to start it, run yarn to install the dependencies, and yarn dev to run the development server and follow the URL. You should see this 3D stage ready for our singer. It's a modified version of a tutorial from Polygon Runway. Check out his courses if you want to learn Blender. Then you can see that the lights are blooming. It's because I added some post-processing effects for the best effect. And you have a few UI elements added with Tailwind CSS. Alright, we're ready to go. What we want to do is to load a VRM avatar in the middle of our scene. The starter pack repository contains a few models that we will be able to use during the tutorial. But first, let me explain to you where you can find yours or even create yours. You have a VRoid Hub that contains many VRM models. Not all of them are available for download or for public use. I don't know if there is a filter somewhere, but usually what I do is I open one I like, and here, can you use this model? You can see it's no, so bad luck. Go back to the lists, open some of them randomly, and pray that this one you are able to use it. Scroll down and it's yes. But sometimes you have used this model and they don't have a download option. This one has, so you just accept the terms and download it. You can also find a VRM model on Sketchfab. Just type VRM and you will have a list of a few. Or if you are brave enough, you have VRoid Studio that allows you to create your own. It has a Windows and Mac app, allowing you to create the avatar of your dream. And they even have a documentation page explaining you how to export your model as a VRM file that you can then later use in a Three.js project. Once you have your VRM file, you will need to load them with Three.js. We have seen that VRM file is something on top of GLTF. It's an advanced file format that relies on GLTF, but with some additional features. And that's exactly what this package is doing, is to provide us some util functions to do the extra work needed on top of the GLTF file. It is made by Pixiv, which are the creator of VRoid Studio. And you have the documentations showing you how to do it. It's meant for Three.js, but together we'll see how to do it with React Fiber. Not a big difference. And you also have examples showing you how to do different things as rendering a VRM, playing animations, and so on. You have the example, the preview of it, but you also have the source code helping you to perform some specific actions. All right, let's load the library. Yarn add at Pixiv/3-VRM, enter. Perfect. Now we can run a yarn dev and we will create a component. Inside our components, we will name VRM avatar.jsx. Let's export VRM avatar. It will take the avatar, which will be the file name, and the rest of the props if we want to move it for the main container. To load the avatar, we will use GLTF. So we'll get access to the scene with use GLTF of models / the avatar. But because it is a VRM file, we need to enhance our GLTF loader. If you look at the documentation, when they create the GLTF loader, they register a plugin, a VRM loader plugin on top of the parser. To have access to the loader with use GLTF hook, you can see it's use Jericho. We will use the default value, so we pass undefined, and extend loader is a function having access to the loader. So inside it, we can perform our actions on the loader. And we simply need to do this, what they are doing here. We can copy paste, be sure that you import VRM loader plugin from Pixiv 3. It should be good. Then we return our group. We pass the props, so we have control over it. And in a primitive, we will pass the scene we loaded. Now let's try to use it. Inside our experience, we will use controls from Leva to have a visual helper to choose between different avatars. We'll pick one default file and provide different options so we can switch between them. Don't forget to import use controls. And now we can import our avatar here next to the stage, so their Y position is perfectly aligned. VRM avatar, our component, and the avatar will be our avatar. Let's try it, and we can see we have our avatar in T-pose, but it's facing backwards. And the issue is some avatars are facing this side, while this one is facing this side. So let's make it conditional. Back to VRM avatar. Rotation Y, if this is not this avatar, the one that is facing toward us, we will rotate it, otherwise it will be 0. It's ugly. For a non-tutorial project, I will code it differently, but here it works. Now, if we look at free range is facing us, and the other avatar is also facing us. Same for all the different ones. Now let's see how we can impact their blend shape, closing their eyes and so on, but also play animations. Let's start with the facial expressions. Because we are using a VRM avatar, we need to do it differently than usual. We won't be impacting the morph target on the skin mesh. Well, this is what the library will do for us, but we will do it ourselves differently because of the VRM library. To learn how to do it, we can open the examples. And the one interesting us is expressions. Here you can see she is blinking one eye and opening, closing her mouth. Let's check the source code of it, packages, then inside ThreevRM examples, and when we use these expressions. And from here, you just have to copy the way they are doing it and adapt it to your project logic, either in Three.js or React 3 Fiber like me. Okay, this is for the loading. We can see they are doing some optimization. Let's try to do them too. Let's go inside the use effect. When the scene is loaded, and we perform these optimizations. They're using VRM utils. They are performing it on the scene. We have it from the use GLTF. No need to use GLTF dot. And then they are combining morphs on VRM. And here is the interesting part. You can see that VRM is equal to userdata.vrm, which means they add extra data in the GLTF file inside user data. I think it's the library doing it when it's parsing the file. To get access to the user data, we can get it from useGLTF. And now we can do like they are doing. Const VRM is equal to userdata.vrm. And let's console log it to see what it is. Now, a few optimization must have been done. You can see we have a steady FPS for now. And in the console, VRM loaded, and we have some details. We have an expression manager object with the different expressions we can do: blink, blink left, look left, some mouth expressions, and some more data, humanoid containing the different bones and so on. All right, that was a quick digression. Now we want to play with the face. And you can see that they are using the expression manager and setting values to them. Easy. Again, here, current VRM. I guess it's simply here, the one from user data. Let's play with it. Okay, we will declare some control to choose how to affect the different expressions. These ones are for the mouth shape, A, E, O, U. Then we have the eyes and some emotions. With use controls, we will have some sliders to affect them. Perfect. Now, in a use frame, we will simply adjust the expressions. Use frame, if we don't have user data.vrm, we can do anything, so we simply return. Otherwise, we call user data.vrm .expression manager .setValue, and for angry, the first emotion, we set the value we have from our control. Then we do it for sad and happy. If we try the different expressions, nothing is happening. Let's check if we missed something. In animate, and they also need to call update with delta time. Let's do it too. We need the delta for each frame and user data.vrm.update, and we pass delta. All right, it was opened as an angry, very scary, sad, and happy. If we combine, it gives some mixed feeling. Perfect. Let's connect the other ones, but instead of doing it line by line, we will create a lerp function. We will name it a lerp expression. It will take the name, what you have here, the value, what you have here, and the lerp factor. Currently, we were not lerping, so they don't exist. And then we do the same, set value for the name, and the value we will lerp from the current value that we can get with getValue, and then we lerp toward the new value with the lerp factor. Don't forget to import a lerp from mathutils. And instead of writing line by line for each emotion, we will create an array with the name and the value for each of them. Then we will iterate and call lerp expression with the name, the value, and the lerp factor. We want it to be fast, so we multiply delta by 12. Let's try it. We have the A, E, it's opening wide the mouth, and you can combine them. O, U. Perfect. So you could use the lip sync tutorial with this avatar too. Then you can blink the eyes, and we still have our emotions. Excellent. Now what we want to do is play animations, because we don't want to see them in tuples always. Again, they have some example for it, animations. It's a very simple one, but you can see how it works. But this one is if you want to control manually bones. You have the humanoid animation to be able to load a Mixamo animation and play it on the VRM model. Exactly what we want to achieve. We need to drag and drop a Mixamo animation FBX. Let's do it. They are on the starter project. Drag and drop, and you can see it's playing the animation. Let's make it dance, and it's dancing. You can see that because it is a VRM avatar, the hair are animated automatically. based on some of the bones contained by the avatar. Of course, you can download the animations you want on Mixamo. Go there and log in. Then go to characters and pick one of the default one, for example, Remy, before going to animations. So you are sure the rig structure is the basic, the default one. Then go to animation, pick one you like, and when you download it, be sure you don't take the skin because you don't want the 3D model. You just want the animation data for it without skin and download. Once you have your animations, let's see how to load them. Go to examples. And the one we want is humanoid animation. It's a bit more complicated because they have some code to do the mapping of the different Mixamo bone to the VRM rig. Let's simply take it. We can copy everything. I think this button is doing it too. And inside a utils folder, we will keep the same naming. It is Mixamo VRM rig map.js. Paste it and save. Then the other one we will need is a load Mixamo animation. And this one is also doing the FBX loader to load the file. So we will modify it a bit, but let's do it together. First, we take everything. Because it's different, we can name it differently. Let's name it a remap Mixamo animation to VRM.js and paste the code. We can get rid of the comments and we want to rename it remap Mixamo animation to VRM. Instead of loading the FBX, we want to plug ourselves directly here because we will pass the FBX directly. So we need the assets and not the URL. It will take VRM and asset. So we can get rid of the loading on top, and the final part, which is here, is doing some processing on the bones. You can just ignore it, or if you are curious, have a look at what it is. Okay, now we can save it, go back to VRM avatar, and let's load the FBX first. So right after loading the model, we can load them. Let's name it asset A, B, and C. Not the best naming, but again, this is just a tutorial. And because with the FBX we will need to call the remap function only once, we will do it inside a use memo when asset A changes, but also when user data.vrm change. Maybe we can do like what they were doing. Current VRM is equal to user data.vrm. Here we use it. And we will have animation clip A is equal to the use memo. And our clip will be equal to remap Mixamo animation to VRM with current VRM and the asset we want to use, asset A. And then we want to name the animation. For that, we can do clip.name. And this one, it's swing dancing. Perfect. And we return the clip. So it's been processed only when the asset is loaded and current VRM 2. We do exactly the same for the clip B and clip C. So now we have our animations. To play animations on a model, to get the actions, we use animations hook. It needs an array of animation clip. For us, it's animation clip A, B, and C. We create an array with those clips. And the scene, we will use current VRM.scene. Then to be able to choose between the different animation, the one we want to play, inside our controls, we will add animation. And we add it here. We'll have idle by default, but we can choose known. It will be the T-pose, or swing dancing, or thriller part 2. Now inside a use effect, when the actions change, if the animation is known, we return. If not, we play the animation, and when it changes, we stop it. We also want it to be triggered when animation change. If we try it, we have a very scary result. This is because when we remap it, we need to do it only once. And because we are in strict development mode from React, it will call the use memo multiple times. Not in production, but in development. So what we need to do here is the clip that we get, we will clone it. This way we are sure that we don't destroy the original animation clip. Let's try it. And now it works much better. If we change the avatar, this one isn't triggered, but let's change the animation and it's working perfectly. Okay, now we know how to control our avatar, the blend shapes, also the animations. Let's see how we can create a VTuber studio using our webcam to control the avatar. For this, we will use Mediapipe library, which is provided by Google, and we will use its lovely face landmark detection guide inside their holistic package. You have web, code example, and guide. And then based on the data we will get from Mediapipe, we will use this library named Kalidokit that will do the mapping for us between our mouth shape, our eyes, and pose to convert it to VRM avatar data. Their documentation is very user-friendly, and their example contains the Mediapipe part, which helped me draft the project very quickly compared to if I had to do it myself. If you go to their script.js, you can see this part setup Mediapipe Holistic instance. They are doing everything to load Mediapipe. We simply have to copy paste it and adjust it to our project. The main difference is they are not using a Blender and a build, so they are doing their import this way, but us instead we can use the npm package. We will need 3 packages from Mediapipe. The first one, holistic, for the face and pose recognition. Then we have camera utils to get the data from our camera to send it to holistic, and then drawing utils to convert the result they get from holistic into something we can represent on screen on a Canva. Let's add them into our project. All right, yarn dev, and let's go back to our code. Let's create a new component that we will name camera widget.jsx. And you can copy paste my component. I will explain it to you. What we have is a video element for displaying our webcam capture. Then we have a canvas where we will draw what the algorithm is detecting from our camera. Then we have buttons to start or stop the process. And then it's the code from the example calling holistic to do the video recognition using our video camera here. And then when we have results, we call a draw result that will draw it into the canvas. And then we will create a store named video recognition to be able to pass the result we have into our VRM avatar component. Let's create this hook, use video recognition. Inside a folder named hooks, use video recognition.js. To create our store, we will need Zustand library, yarn dev. Now we can create our store. We will need access to the video element, which is the one from our component, and then a results callback function that we can call to interconnect our widget with our VRM avatar component. Now let's try to add the component inside our app. We have the UI. We also want our camera widget component. On the bottom left, you have this camera button. If it is the first time, it will ask for you some permissions. And now you can see it's detecting my face and it's drawing different things. It can see my hand because we enabled the pose mode, everything we need. Now let's try to interpret this data inside our VRM avatar component. We will need to access 2 things from our store. First, set results callback, which will be a function that will be called once the detection is done, and video element to have access to the video for the recognition itself. Now to prepare our results callback function, we will need a few variables: rigged face, rigged pose, left hand and right hand. This is where we will store the data we get from the callback to be able to apply it later inside our use frame without causing any re-render. Inside our callback function, we will need to use Kalidokit to get those data for the face, the pose and the hand. What we need to do is to call kalidokit.face.solve and face landmark array, which are the data we get from Mediapipe. Then it requires the video element to be able to do the transformation, and we do it for the face, the pose and the hand. We create our function in a use callback, so it doesn't recreate it at each re-render when the video element change and current VRM. Then if we don't have any of them, we can do it, so we just return. Otherwise, we can do the processing. So the callback function takes results as a parameter, and it has access to face landmark. Inside our references, riggedface.current, we will use face.solve. We pass face landmark, and then adjust the parameters to whatever works best for you. Just be sure to use the same runtime that you are using, as it is Mediapipe. Same for the size of the image that need to correspond to the input camera you are using. If we go to camera widget, we are using a 640 and 480. Good to verify because as it is the opposite with an 8. And we do the same for the pose and the left and right hand. I needed to switch which one is the left and right to match what I have as a mirror effect. Now we have our callback function. In a use effect, we can assign it. So we have our results callback. We need to set the result callback to it. First, let's check if the connection is working. Here we can console.log the results. Let's try it. By default, we don't have anything. We need to enable the camera detection. And we have an issue because I didn't do the import. Here it is, face. It needs to be from Kalidokit. I think I also forget to install it. Yarn add Kalidokit. Okay. Now I should be able to see it here. Perfect for the face, pose, and hand. Okay, let's try it again. Now you have the camera and we can see what we get. We have the image, the canvas. We have face landmarks, but you can see the data, it's unreadable for us. It's what we see on the canvas. We wouldn't able to manually convert it to blend shape. And this is where Kalidokit, if instead we don't log the results of this, but inside our use frame, we can go below console log and riggedface.current. So rigged face, this is what we get from face.solve based on face landmarks. And what Kalidokit does for us is incredible. We have the eyes, the head, their position, the mouse, pupil, and on the mouse you also have the shape to know which blend shape to show. We can simply use it instead of our values from our controls. We can make it conditional. So if we don't have a video element, we are not in facial recognition, so we can just do it conditionally here. Otherwise, we do our processing. If we have riggedface.current, we create our array, but using riggedface.current.mouth.shape. And for the eyes, it's the same, but it's 1 minus the value. And then through each item, we call lerp expression the same way we did before. Let's check what we have. Enable the camera. If I open my mouth, you can see it's opening it too. And if I blink, it's doing it too. Excellent. Then we simply do the same logic for the rest. For the eyes, we look at a target based on the pupil. Then we have some data for the rotation of the neck, for the rotation of the different bones in a rigged pose. We do it for each of the different bones of the arms and the hand. We create a generic rotate bone function as we did for the lerp. And to make the character look in the same direction as us, we are using the camera, and we create a target that will be equal to where the camera is looking at. And now we are able to control the avatar, its eyes. Let's disable the animation so we can control the hand and sing nicely. Thank you for watching. I hope you enjoyed this video. Please hit the like button to help this channel be more visible to other creative developers. Don't forget to subscribe to not miss my upcoming tutorials. If you want to continue your 3D web development journey, give a look to my course, link in the description, or watch one of my other videos like this one, available here.